Forest Mensuration lecture number 17. So there was a series of lectures from Forest Mensuration lecture number 11 to lecture number 16 where we discussed about the tangent method for right angle triangles for vertical trees, and we were also discussing now for the leaning trees, either it is away from the observer, leaning over towards the observer, on the slope or different situations by sine method. So this is my last lecture for the trigonometry. There are some cases left of leaning trees. So let's understand about the sine methods. Already this is error. For this error, either it is away from the observer or it is towards the observer. We will be studying about the different cases by taking the theta angle, and already in my previous lecture many times I told about the sine rules. Many times I told about this. These are the very important things because this will play an important role for the calculation by trigonometric sine law for those things. And among that one, this is very important. The first one, sine 90 degree minus theta is equal to cos theta. This exterior angle property is the third one. We should also never forget this exterior angle property, where property 1 tells the sum of three angles is equal to of a triangle is 180, and the exterior angle of a triangle is equal to the sum of two interior opposite angles. These are the three things to remember. We should never forget. Now this case 2. Case 2, observer is below the bottom of the tree. See, you can see observer is very below and is uphill, but it is leaning what? Away. Now it is leaning away from the lean tree, and we'll have some small calculation in which one we have to just keep in mind. That is important. Already I am telling you here we need to find what? We need to find EAB. So always we need to find EAB, because EAB we have to put it here. So when we go for EAB, EAB and A we don't know here, the angle we don't know here. To find this angle, so first we'll find CAB. So whatever, if we can able to find CAB, we can find your EAB, because both angles are same here. So how to do it? Now in this case, we can see again the eye, observer eye is below now. Again is a sloping. You can see the tree AB is leading away, and the tree is above the observer. You can see the tree is above the observer here, above the observer here. So in this case, how to take the height of a tree? Again we'll take the sine method, but before taking the sine method, we'll understand this one, how to do it. Now first is AB is the tree leaning away from the observer. Here you can see it is leaning away from the observer. E is the observer eye, and then we have to make this vertical line is there. We can see one vertical line starting from C. We have to make it 90 degree. Okay, we have to make it 90 degree. That is, we can see this vertical line, either we can say BC or DC. This BC, when we make, we have to take a theta. This is a leaning theta. Theta we can get it from here, from that. Very easy to take theta, already have I explained you. This we can get from a clinometer or at this level. Both are angle of elevation. We can get beta and we can get alpha. Beta we can get up to, we are taking the degree up to B, and the base of the tree we get a beta, but when we take up to this A we get an alpha. So we can minus it. This is alpha minus beta comes this one. So this is our exterior angle. This is our interior angle. Now first of all, before we go to sine law, we have to take out the exterior and interior angles. So let's come to the triangle ECD. This is ECD. This triangle we have made a 90 degree here. Okay, this triangle we have made a 90 degree here. So for this one, if this is 90 degree, this C will be 90 minus alpha, because this entire CED is alpha. This is entire alpha here. Okay. Up to BED is beta. Okay, so this is, we can get 90 minus alpha, and this 90 we can get in a CED. Now in a triangle ACB, because this we need to calculate. Okay, if we know this CAB is equal to EAB, both triangle are same. Either we say EAB, either we say CAB, both triangles are similar. So first we will calculate this one. To calculate this one, again the same thing will go. Already I explained this law of property number 2, that is called exterior angle property. Exterior angle of a triangle is equal to sum of two interior opposite angles. Now this we need to calculate CAB. If this is exterior, if you minus this one interior from this exterior, we'll get this one. So you can see in a triangle ACB, CAB, this we need to find. This angle we need to find. This angle we need to find. So to find this angle CAB, what is CAB? Is exterior ECB minus interior CBA. This is the same property number 2 of the exterior angle property. So let's put the value here. Exterior ECB is 90 minus alpha, 90 minus alpha, and interior CBA, this is interior, is what? Theta. So we get this final 90 degree in bracket alpha plus theta. Okay, so once we get CAB, this one is same thing. EAB angle is same of CAB. So our objective is what? Our objective is to get EAB. To get what? EAB, this one, to put in the sine law, this formula. So what we will do? This is sine law. AB is equal to EB sine AEB. What is AEB? AEB is always what? This alpha minus beta. So AEB will put it here, alpha minus beta. EB sine AEB, in AEB will put what? This one, sine alpha, sine, what do you say, in bracket alpha minus beta. And what is EAB? Just now I told you EAB is our main target. So to get the EAB, this angle, we have just solved this one. Okay, we have solved this one, we got it, and we'll put this 90, this one, this one in EAB. This in EAB we are putting here. So sine this EAB, in EAB what is 90 degree minus alpha plus this one, and this again trigonometric ratio. What is the trigonometric ratio? Sine 90 minus theta is equal to cos theta. So this sine will become cos, and this will be again alpha plus theta. So this will become cos. So we can get that height of a tree when it is leaning away from the observer and when tree is above the observer height. Next is case 2. In this case, observer is below the bottom of a lean tree. Again it is bottom of the lean tree, but here what happens? Now tree is towards the observer. When the tree is leaning towards the observer, then we will find this one height of a tree. Now this angle EAB, again EAB we have to find, very simple. Again this is the exterior angle and this is the interior angle. So that property number 2 we will apply for this one to find the interior and exterior angles. So how to do it? In this case, when again the tree is above the observer eye height, you can see from the observer view it is again above, but it is leaning now towards the observer, means it is overestimated. You can see overestimated. So same thing again, we'll make a triangle like this. Before the sine law, we'll just revise it. See, we can see AB is the height, we need to find the height. This is the observer eye, this is the BC of the vertical line. At 90 degree we are getting 90 degree. When this is 90 degree, then ECD is 90 minus theta, and this is 90 minus alpha. Then this ABC will be theta. This we can take from the device, the angle of the leaning tree, theta we can get it. This we can know. This we can know by making this 90 minus alpha, and this both angle of elevation is there. One angle we are getting from the instrument clino or Ebnis level, taking from 0 to here. When we reach here, we get an beta at the base. We'll note this one, and then when we take the top, we get an alpha. So we can get alpha and beta as the angle of the top and the base, angle of the top and the base. Theta is the angle of CBA, this one leaning tree angle we are getting. Now what we will do? Let's go to the exterior and the interior. This property, first we'll go to this property, get property number 2. So if the property number 2 tells us what? That exterior angle EAB is equal to interior ACB plus ABC. So very simple. let's find this EAB. What is EAB? Angle EAB is what? Is sum of two interior angles. What is the sum? ACB. ACB is what? This one. 90 minus alpha plus what? ABC. What is ABC? ABC is theta. This theta. Okay. So EAB now becomes 90 here by simple algebraic way. This will go under bracket alpha minus theta. This we are getting the value of EAB, which we could not find. So this is very important. We got it now. Now next step is sine law. In sine law again, what it says? It says AB is equal to EB sine angle AEB divided by sine EAB. EAB we are getting from here. This one. On AEB is what? This again this alpha minus beta. So we'll put the value here in AEB. This we are putting this alpha minus beta here, and then in sine EAB this one we got it here, 90 minus this alpha minus theta. We are putting this value here in EAB. This value EAB we are putting here. So this now again the same thing. This sine will become cos by trigonometric ratio. As I told you, this sine 90 minus theta will become cos here, and this will remain same, and we can find out the height of a tree when the tree is leaning towards the observer. So this way we can find the height of a tree. Now case number 3. In case number 3, now observer is above the top of the lean tree, but the tree is what? Tree is away now. When tree is away, we can see we are having two triangles here. We form a two triangles here. This is very important. These two triangles are opposite triangles. We can see it is an opposite triangle. You have ECD or DCA, they are opposite to each other. So when they are opposite, always we find that in the C, if we know 90 minus alpha, 90 degree minus alpha is C, you will have this again C is 90 minus. So this way, if we don't have triangle here, we don't know, we can find it by opposite angle. So opposite rules are angle are same for C. So this way we can find. So let's understand. This is the case when the tree when the observer is above the tree. Now you can see is above the tree when the base and the top is below and the observer is above. This is a slope here. So in this case, how you will find the height of a tree? When the tree is leaning what? Now away. Now when tree is leaning away, you can see this is AB is the tree, and E, you can see E is the observer I, and again we have to give a 90 degree. We have to to find this one, we have to make a 90 degree angle. We have made a 90 degree angle. Vertical line is BD here. So you can see 90 is here. If this is 90 and this, we will take an angle EDC. When we take this angle, in this angle this is 90 degree, it will become 90 minus alpha, because this was alpha. Because we have taken an instrument again, kilometer, and this was the zero level where the straight is a 0 degree will come here. So as we go to the angle of depression up to this tree top, we'll get an alpha. Whatever degree we'll get it alpha. So this is 90 minus alpha at this angle. ECD is 90 minus alpha. And when we go more, we take the angle of depression to the base, we get a beta here. So first we'll try to understand this ECD. So ECD, we are getting this value we are getting here. Now before that one, let's understand again, this is theta. Already I told you this angle of leaning tree, we get it theta. Okay, how this value has come 90 minus alpha? This is a simple law, because you see ACB ECD, sorry, in angle ECD, this ECD, already I told you ECD 90 is here, 90 minus alpha is here, this is alpha, equal to ECD equal to 90 minus alpha, this one is ACB. Now this ACB is being on opposite angle. You can see it is an opposite. This is just opposite. This is an opposite. This is an opposite angle. When this is an opposite angle, C will be equal to here. Whatever angle you are forming at ECD, then ACB, this angle will be same. So this angle at C will become 90 minus alpha, because this is just because of the opposite angle. Now we are getting this angle here by getting the angle from ECD. Now we are getting ACB. This will be 90 minus alpha, being opposite angle. So it is solved here. Now our objective is what? Our main thing is EAB. To find in a sine law this EAB, how to get EAB. Now this angle, we don't know what is this angle here, EAB. So how to find this angle? Now we'll go to the property 1. Sum of three angles of a triangle is 180. Sum of three angle of a triangle is 180. Sum of three angle, this one, 180. So we have to find CAB, or we have to find BAC, whatever you want to find. So in CAB is equal to 180, because from 180, if we minus this 2, we'll get that angle. So 180 minus ACB plus ABC. What is ACB? ACB is this 90 minus alpha, this one is this one, and ABC is theta, this one. So we minus it after simple algebraic way, we get it 90 degree plus this, we minus by this one, we'll get a 90 degree. This is alpha minus theta. So we can derive it from here to here. So this way we are getting ACB. So ACB, we got it. Now let's go to what? We'll go to the sine law. Sine law, the same sine law. AB is equal to EB sine AB divided by EAB. See, AB is equal to EB. EB, this is a distance we know already, horizontal distance we know, into sine, what sine? Sine of AEB. AEB, what is AEB? AEB is beta minus alpha. See, beta minus alpha we are getting in AEB. And what is sine EAB? Sine EAB. EAB already we have calculated just now. What is EAB? This is EAB. EAB, just now we have calculated this EAB. So EAB, we are putting the value here. EAB 90, this 90 plus alpha minus theta we are putting. Now what this sine will become cos? Sine will become cos by trigonometric ratio of this one. Sine 90 minus theta is equal to cos theta. It will become here. This sine will become this cos here. So this way, this is the final formula. To calculate this one. Sine 90 minus theta will become this cos. So this way we can calculate the height of a tree when a tree is leaning away and from the observer, and observer is on the height where the bottom and the top is below the observer. We have gone through that calculation. So in the first one is the opposite one. The first case we have gone through opposite. Second case is what? The property of one. Property one of that. What is the property one? CAB. In CAB we have what? All the three, sum of these three angles will be 180. So 180 gives us a clue how to know about the third one, that is A. Now we'll go for the next, that is height of a leaning tree. In the case number 3, in this case number 3, observer is again on the top, but here the tree is now what? It is leaning towards the observer. When it is leaning towards the observer, here the case is bit difficult now. Before that one, I'll tell you, you can see one triangle is EDC, another triangle is ECB, and one more triangle is coming here, EAB. So you can see here is one triangle, here is another second triangle, and here is a third triangle. So first, in the first case, we will consider this triangle EDC and ECB. Then we will, by this will be the exterior, this will be the interior, and later on this will be the exterior and this will be the interior. So how to do it? Let's understand nicely. So this is the last case in which the tree is again below the observer. You can see the tree is again below the observer, where the tree is leaning toward the observer. So it is now overestimated. So we can see this one. This is the triangle, And EAB, again EAB we need in a sine law. This is very important, this one EAB. So we have to calculate this portion. This is, we don't know. Okay. Now for this one, again interior and exterior angle we have to find. To find this one, first we have to find this angle. Okay. Now how we will do? First let's understand one by one. This is AB is the height of a tree which we need. E is the observer eye. Okay. EBC or CBA is the theta. What is the theta? Theta is the angle of the lean tree. This is the theta of the lean tree. So this alpha angle is the angle of depression. The first one, we are making an horizontal line up to DED by an instrument, getting a 0 degree. As we go down, taking up to the top of this top of this degree here we are getting degree, that is alpha. We'll note down this reading. Again we'll go down to the base, we are getting beta. These both angle of depressions are there. So we can get alpha, we can get beta, we can get ED by horizontal distance, this one. We can get this theta leaning tree. Now we'll make a vertical line by this theta. This is BD. So we'll make this triangle after this for the calculation and assume this is, we will take 90 degree one, because this is, we are having a straight line BD and ED. This is 90 degrees. So what will be ECD? ECD will be 90 minus alpha, because this is alpha. This is 90. This is 90 minus alpha. So now let's come to the first case. There will be two cases here. First is, we have to take exterior and interior angle. In angle ECD, ECD, this angle we are taking in first, this angle we'll discuss. Now exterior ECB. Now we are not taking this exterior EAB. This will take later on. First we'll try to find this one ECB. This is an exterior angle ECB. This is an interior angle. What is interior now here? DEC or CED. This is interior. So exterior angle ECB is equal to interior of 2 times interior of this one. We can say CED or EDC. So let's find this angle now. First we'll find this angle, number 1. To find this angle ECB equal to what? Interior CED. CED is alpha. We'll put alpha here. Plus EDC. EDC. What is EDC? EDC is 90 degree here. See, 90 degree here. So it becomes 90 degree plus alpha. We got this one. This one is 90 degree plus alpha. Now this is solved. Now we'll solve EAB. This is what we want. This is what we want in sine law. Now how to do this one? This is, now we'll make this exterior angle EAB. Now what is EAB? EAB will be equal to what? 2 interior. What are the 2 interiors here? Interior ACB plus ABC. Now let's take what is EAB exterior. Let's equal to what? Equal to interior ACB. ACB. What is ACB? ACB, just I told you this one. Isn't it? We'll put it here, 90 plus this alpha plus ABC. ABC is theta. This theta we are putting. So 2 interiors. One interior is this one, another interior is this one. We are plussing. So after plus we get this one 90 plus. This will go in the bracket, right? So we got EAB. Now in the sine, this is same formula in sine EAB. Let's come to that one. Sine law, what AB? AB, this AB height is equal to EB sine AEB. EB horizontal distance, EB horizontal distance sine AEB. Sine AEB. AEB is beta minus alpha. Beta minus alpha. Beta minus alpha. Beta minus alpha. So we'll put this AEB value here. We got it, this one. Divided with what? Sine EAB just now we calculated this one. So we'll put the sine EAB here. This value we'll put here. Just now we have calculated this value. This value we got it from here by this property number 2 of exterior angle property. We got it this one. Now EB, this EB sine beta minus alpha is this one, divided by this will become what? Cos. How it becomes cos? By a trigonometric ratio. Sine 90 minus theta is equal to cos theta. So we get it here. This by this trigonometric ratio we have converted this sine 90 minus theta into cos, and this is the same, alpha plus theta. So this, by this formula, we'll get the height of a tree. So first we will solve ECB, and then we need to get C here because C is very, very important. Then later on, the next we will get for A. So we are solving here two exterior angles. So it's not very typical. So once we understand trigonometry nicely, we can solve any type of problems in forestry. Now again, I'm telling you, we have tangent method. That is very simple tangent method when it is a vertical tree and maybe sloping ground, maybe a level ground. Another method is sine method, when trees you cannot make a right angle and then it may be leaning towards observer or away from the observer in difficult terrains, in the slopes and different situations. So we can calculate by trigonometry method. And now as I culminate this entire trigonometry method, but before that, height is very, very important factor as we consider by to calculate the volume of a tree. So let's have a height class. Just in a small, what is height class? I want to tell you, height class is defined as one of the interval into which the range of a tree height is divided for classification of use. Now why we are putting height class? Because forestry is a huge area, lot of trees are there. If it is for research purpose or for very specific purpose, then we can have a height for individual trees. But when it is in a large, in a group, stands are there, so we have to ultimate come for easy way to make a class. So that is called height class. So how we will group this height class? We have divided like this height classes in 3 classes. We have divided. One is 0 to 5 and 6 to 10 and 11 to 15, so and so on. Other one height class is 0 to 3, 4 to 7 and so and so. Others 0 to 1, 2 to 3, 3 to 4. Like this we will do. Let's understand. But how we do it? This we do it for such cases. Number one cases is that if you are having height of those trees in mature trees or maybe maturity, the height of the trees which crosses more than 25 meters, in such cases we'll keep the height class that is 5 meter. 5 meter mean to say 0 to 5, 6 to 10, 11 to 15, like this. And these are some species like Shure robusta, species like Bombyx. So this is important for us to understand that what are the height classes and to which species, which trees will give this height classes of 5 meters. So this is height classes for the long trees where their height crosses more than 25 meters when they are at mature trees. Second one is those trees where the height remains from 15 to 25 meters at maturity. So those trees, there are a lot of species in these categories. So in these categories, we'll keep the height class of 3 meters. 3 meters, I mean to say that 0 to 3, then 4 to 7, like this way we can keep, and 3 meters. So this is for the case like Chucrasia tabularis or Azadirachta indica and so and so. And the third case is that those trees where in maturity it doesn't go in more height, it remains up to less than 15 meters. So those trees which remain up to 15 meters will keep the height class of 1 meter, not more than that. We can keep 0 to 1, 2 to 3, 4 to 5, like this. So this is the height classes. Like we have lot of species in this height classes in a dry zone, in tropical areas where like Prosopis juliflora, Acacia catachus, there are a lot of trees for height classes. So I have completed the diameter, how to measure the diameter, and I have completed how to measure the height of a tree by a ocular, by a non-instrumental method, by instrumental method. Now in my coming lecture, that is very important, how to calculate the volume. But before calculating the volume of a tree, we should know the form factor. Form factor is the taperness of a tree, because this will taper slowly in the upper. It will go in the less diameter. In the base it will be more diameter, in the upper it will be less diameter. It will not be cylindrical. So trees have a habit to go slowly taperness. So there are different type of taperness. Some taper very fast, some taper very slow. So it tells us the form factor. So we'll understand first form factor, then we'll calculate the volume of a tree. So in my upcoming lectures, keep watching for form factor, as that is very important to calculate the volume. Thank you very much for watching this entire lectures. Thank you.